Good morning. Hi, Sushmita GS, Assistant Professor, Department of Civil Engineering, Sai Vidya Institute of Technology. Welcome you for the course Fluid Mechanics. So, firstly, we'll see the complete syllabus and the course details of this particular subject. So, first of all, we'll see what are the objectives of this particular course. So, as we have five modules, we have five objectives. So, the very first objective of this particular course is to make the students to learn about the fundamental properties of the fluids and its application. So, secondly, to learn about the hydrostatic laws and its application to a practical problem. And the third objective is to learn about the principles of kinematics and hydrodynamics for a practical application. And the fourth objective is to learn about the design of pipes and pipe networks. So, considering the flow, pressure, and its losses. So, at last, the fifth objective of this particular course is to learn about the basic flow rate measurements or flow measuring devices. So these are the five objectives or the aims or goals of this particular subject. So where the students is going to learn. So next we'll see the complete syllabus. So and the syllabus is as per the choice based credit scheme. And here, so as we know, so we have five modules, and for each module we have a different hours has been allotted. So we'll see what is the syllabus of the first module. So in the very first module, the students is going to learn about the fluids and their properties. So basically, a fluid mechanics means it is the study of fluids, so with in rest as well as in motion. So here basically the fluids may be water, petrol, or any kind of a fluids. So the first module they are going to study or about the introduction to, to the fluids and their properties or characteristics. So that is what is a fluid and what are the different system of units are available, and also the different characteristics or properties of the fluid like mass density, specific weight, specific gravity, specific volume, viscosity, adhesion, cohesion, viscosity, so and other related problems, and also so properties. And so we are going to solve some of the problems related to some of the properties like viscosity and surface tension. So in the module 1, we have two parts. So the first part is fluids and their properties. So these are certain examples, so pictures of the different properties of the fluids. So and the second part is fluid pressure and its measurement. So here we are going to study about, so what is the pressure, that is the definition of pressure, and the two important laws we are going to study, that is Pascal law and variation of pressure with depth, which is also called as the hydrostatic law, and the different types of pressures, atmospheric pressure, gauge pressure, absolute pressure, and what are the devices, majorly the manometers, those are the pressure measuring devices. So we are going to study so the different types of manometers, and also we are going to solve some of the problems on that pressure measuring devices. So that is what include in module 1. So these are also some of the examples for the properties of the fluids. So coming to the second module, so the total number of hours is 8 hours, and here also you have two parts in a module 2. So one is a hydrostatic forces on surfaces. So in fluid mechanics we have three branches. One is fluid mechanics, so is subdivided into fluid statistics, fluid kinematics, and fluid dynamics. So in the first module you're going to study only the basic concepts, properties, characteristics, or the introduction, the definition of the fluid. So whereas comes to the module 2, so here you're going to study the two branches of fluid mechanics. So that is hydrostatistics, which is nothing but the fluid statistics, and fluid kinematics. See, what is fluid statistics means? It is the study of fluids in rest. So as well as, so fluid kinematics means, so it is the study of fluids in motion. So whereas fluid dynamics, so that you are going to study in the module 3. so which is nothing but the study of fluids in motion, but there we are going to consider what are the forces which are responsible for that particular motion. So whereas in the kinematics we are not consider the forces which are responsible for the motion of the fluid. So in the hydrostatic forces on surfaces, so we have four different surfaces, that is horizontal, vertical, inclined and curved surfaces. So all the four are derivations. So we are going to determine the what is the total pressure force which is exerted by the fluid. So on horizontal, inclined, vertical, on curved plane surfaces. So those surfaces are in rest. All the surfaces are in rest. Okay, and later you're going to study about the gravity dam and a log gate. So those are the applications of that hydrostatic forces. So and you're going to solve some of the numerical problems on all those four derivations. So, and coming to the second part of the module 2, in the module 2, in the second part, you're going to study about the kinematics part, that is the motion part. So, so you have different types of, different methods of describing that fluid motion. So, methods and also, so majorly what is the velocity of the fluid and what is the acceleration of the fluid. So, those are the characteristics of the fluid flow. So, and also different types of flows. So, and flow patterns, you're going to study what is the pattern of the fluid when it is in motion, and certain basic principles also you're going to study. And the most important derivation, that is three-dimensional continuity equation in Cartesian coordinates, you're going to study in the second part. And also two types of functions, that is potential function and stream functions, which are the characteristics of the flow of the fluid. And you're going to solve some of the problems on those two types of functions. So that is the what you're going to study in a module 2. So in module 3, so as I told, the third branch of the fluid mechanics, that is fluid dynamics, you're going to study. See, dynamics means you're considering, dynamic means force. Okay, so you're going to consider the forces, so which are responsible for the motion. So we have different various types of forces, so which acts on the fluid. Okay, when the fluid is in motion, for example, if the river water is running in a river, consider a river water, so means the water is in motion. So at that time, so there will be so many different forces will act on that water. So those forces, different forces you're going to study. And the other most important derivation, that is Bernoulli's equation, starting with Euler's equation. So that is a very important derivation what you're going to study here in the module 3. And also the what are the assumptions which are made to derive that equation, and what are the limitations or of that Bernoulli's equation. And you're going to solve some of the problems on that application of Bernoulli's equation. And later, the application part of that Bernoulli's equation is Venturi meter, orifice meter, and pitot tube. So those are the devices, experimental setups. So you can see in the fluid mechanics laboratory. So those are the laboratory experiments. So which are where we are going to use the Bernoulli's equation, and we are going to solve some of the numerical problems on those applications of the Bernoulli's equation, that is Venturi meter, orifice meter, and pitot. So here you can see both Venturi meter. The first figure is the Venturi meter, and the second is orifice meter. And in the fourth module, you're going to study about the flow measuring devices or the discharge measuring devices, that is orifice and mouthpiece, and notches and vias. So for both these, here also you have two parts. One is orifice and mouthpieces, and notches and vias. So all four are discharge measuring devices, and all are experimental setups. You're going to conduct the experiments in the next semester. So for this particular uh, module. So we have in the first part, that is orifice and mouthpieces, so you're going to study. So what is orifice, what is mouthpiece, what is notches, what is vias, and we have various different types of all orifice flow measuring devices, that is different types of orifice, mouthpiece, notches and vias. So all the classification of those devices you're going to study. and the discharge equation. So majorly we are determining the Q. So for that you need a discharge equation. So those discharge equations you're going to derive it here, and also you're going to solve the problems on those discharge equations. So here you can see the practically where the notches are installed. Here you can see uh, in a very small stream, a triangular notch has been installed. We have different types of notches: rectangular, triangular, trapezoidal. So these are the notches which are installed in the field, and this is an orifice setup, orifice meter setup. So, and coming to the module 5, so in the module 5 at the end, as the fifth objective says, you're going to study about the flow measuring. You're going to study about the design of pipe networks. So here you're going to study about the flow through pipes. So as we know, when the flow is occurring in a pipe network, so there will be certain losses, that is major and minor losses, and we have a very important derivation, that is Darcy's-Weisbach equation. So for a head loss due to friction, so there is a very important equation. So and you're going to solve some of the problems on that head loss equation, and after that you're going to study the different concepts, like when the pipes are connected in series, what is the head loss, and when it is connected in parallel, what is the uh, head loss equation, and also minor losses you're going to study, and certain problems you're going to solve and on the losses equation, and the majorly a network, pipe network. So you know the pipe network, you have to, if you're designing any of the distribution network for a particular city, you should know all these details. You should know what are the losses occurring in that particular network. So to design the pipe network for a particular city, so you should study or you should know some of the concepts. For that particular purpose, you're going to study this fifth module. And the second part in the fifth module is the surge analysis. So in the surge analysis, you're going to study the water hammering effect. The water hammering effect will occur in case of dams or a hydroelectric power plant. So when we are withdrawing the water from the dam to the power station, so then what happens? It will be the length of the pipe will be very large, because the water we need to uh, extract from the dam for a very large distance, because we should get a very high head to obtain or to generate the power. So at that time, so water will be under a high velocity. So at that time, it will exert a hammering effect, okay, on that pipe. So that for that purpose, to avoid that hammering effect, so that pipe should not destroy or it does not break, you're going to study this particular concept. So there you have two cases. One is when you close the valve gradually, or when you close the valve suddenly. So what is the equations for that pressure rise you're going to study, and also you're going to solve one or two numerical problems on those two derivations. And at the last, so as we have stated initially the objectives, at the end, what is the outcome after studying all these five modules? So after studying all these five modules, you should understand something and you should get some outcome or output. So for example, if you are giving an input for a particular program or a computer, you should get some output. So like that, here also the initial objectives, whatever you have made, it should at the end it should meet those. You should attain those goals or aims or objectives. So those are called the outcomes. So as we have studied all the five modules, for each module we have one course outcome. So that is, once you complete this particular course, you should able to understand the fundamental properties of the fluid. So that is the first course outcome. So similarly, after studying the second module, so you should analyze and solve the problems on hydrostatics, and also the practical applications. You should analyze and solve practical problems. So that is the second course outcome. So and the third one is you should study the principles and laws. So you should able to apply those principles in the practical problems, whether it may be Bernoulli's equation or any other law of conservation of mass, the principles of mathematics, you should apply those principles in the practical problem. You should be in such a stage. That is the third course outcome. So the fourth one is you should evaluate the discharge through the gears, notches and orifices. So that is the fourth outcome. So, and the fifth is you should analyze what are the losses occurring in a pipes. So, using those equation, whatever you have studied, so you should able to calculate what are the losses occurred in the actual pipe network for a particular city. So, these are the 5 core outcomes. So, once you complete this course, you should able to do all these, or you should get this knowledge. And coming to the application part of this particular course, you have various, this particular fluid mechanics is applied in all the branches of engineering and medicine. So it is medical, civil, mechanical, aerospace. In all those fields, you can see the applications of this fluid mechanics. See, for example, aeroplanes, in the design of aeroplanes, refrigerator, air conditioner, dam, and pipe network, and also in case of canals. In all those fields, you should have a knowledge of, or the concept of fluid mechanics is used. So, and you have the textbooks. So, these are the textbooks, that is our textbook of fluid mechanics and hydraulic machine by R.K. Bansal, and hydraulics and fluid mechanics, including hydraulic machines by P.N. Modi and say. So, these are the different textbooks available. So, and you have reference books also. So, that is, so I'll refer you, I'll tell you to refer Fluid Mechanics and Hydraulic Machines by K. Subramanya. So, and also, so the same author have published another textbook, that is Fluid Mechanics and Hydraulic Machines, so including problems and solutions. So these are some of the reference books for your reference, and thank you. So this is the complete syllabus or course details of this particular course. So we'll just continue in detail each module in the next class. Thank you.